Hi, I'm Joyce Tran, and I work as a researcher at the National Institute of Health. So essentially what I do is I investigate biomarkers, which are just proteins, related to Alzheimer's disease. So I work at the National Institute of Health, and the main campus is in Bethesda, Maryland, but the branch that I work at is in Baltimore, Maryland, which is just about 2 hours away. So essentially what I do is I run all the experiments, I plan the experiments, and I gather the data, and then I tell my boss, which is the principal investigator of the lab, is what I'm doing and how that kind of furthers on the type of research that we're trying to do in the lab. Yes, I'm a biochemist. I am a biochemist by training, so I graduated in 2016 with my biochemistry degree, and that's pretty much what I'm doing now, using mostly biochemical techniques. So I wanted to become a biochemist pretty much when I was younger. I really liked doing science. I enjoyed different things about science, and I really liked bio, and I really liked chemistry, and I didn't know what to major in when I went to college, and so I thought, okay, let me just try biochemistry. If I don't like it, then maybe I can, change it later. But I ended up really liking it, and so I kept continuing that pretty much all 4 years of college, and then I graduated with my degree in biochemistry, and then here I am. So there are different levels of biochemists. The lowest level is after graduating a 4-year university with a biochemistry degree, you can go ahead and do anything in the field. Most people end up doing research, and so they become research technicians, or they work for some kind of company doing tech work. And if you want to do other things, if you want to run a lab, or if you want to work for a big company doing things like idea management or project management, stuff like that, you would have to go and get a PhD, which is pretty much 4 to 6 more years of training after doing a 4-year bachelor's degree. And then after doing the 4 to 6 years, you go and do a postdoc for some jobs. And essentially what a postdoc is, it's a post-doctorate degree, and you just pretty much do it to gain experience. So you get paid a little bit, and you're mainly trying to get experience to get a better job. So my schooling experience, it's just at the basic level. I just graduated with my biochemistry degree about a year ago, and right now I'm doing a fellowship here. And a fellowship essentially you can do anytime in your life, but most people do it right after getting a bachelor's degree, and it's for 2 years, and it's essentially you gain experience, maybe solidify what you want to do in the future before applying. So right now I'm applying to graduate schools in order to get a PhD, and so that I can have more variety of different jobs that I can enter into. So as a fellow, I don't get paid too much. I get paid about $30,000 a year. But for people who have more experience, such as a postdoc, someone who has finished their doctoral degree, they get about $50,000 a year, which is really not that much still. After getting a postdoc, though, you can get a job at a pharmaceutical company or running a lab, and I think the minimum you can get is about $100,000, and it goes all the way up to $250,000. So my working conditions are really great because I'm working in a government institute. So we come in 8 a.m. or 9 a.m. and we leave at 5 p.m. or 6 p.m. It's really flexible, so if I wanted to come in one day at 10 a.m. I could. If I wanted to leave early at 3 p.m. I could. I didn't have to tell anybody, I can just do it. Essentially it's whatever project you're on, whatever experiments you want to do, you run it on your own time, and then you just go in, complete all the things you have to do, and then you leave. And of course you want to plan something that's takes about the time of a regular working day, so 9 to 5 or something. Sometimes it goes on a little longer, and sometimes it's a little shorter, and you can plan it as long as you want. And it's up to you, and it's also up to your principal investigator to dictate exactly how long you should be working there, and if you can work holidays. One good thing about this is that if I wanted to take a week off, I could, and then I could just come in extra days on the weekend to make it up or something. So my daily work life is pretty simple. I wake up every day around the same time, 8 o'clock, and then get ready, get a ride to work, which is about only 2 miles away, so I live pretty close. And then I just do a bunch of different things. So I can do an experiment, which I planned the previous day, which is bench work. So I'm at the bench, I have different reagents, I mix them together, I look at different things going on with the chemicals, and then I can gather the data, look at the results on a computer, different things like that. And so it's a balance between working at the bench and then doing data analysis on the computer. So because I work with Alzheimer's disease, the main protein that is involved in Alzheimer's disease is amyloid beta. And this is a very, very large protein. It's made of many elements, and so I can't really give you a structure for it because it's so large, but I can tell you a little bit about it. And so it's a small protein, and what it does is it kind of sits around in the brain, and over time this protein gets accumulated as you wake up or walk around and do your daily life, and then when you sleep it gets removed. It gets cleared from the brain. And in patients with Alzheimer's disease, essentially what happens is their removal system goes wrong, and so the protein keeps clumping together, and it essentially kind of makes this giant clump in the brain, and it prevents patients from thinking, from remembering things. And so a big hallmark of Alzheimer's disease is dementia and memory loss, and an ability to form new memories. So in terms of what I use the molecule for, I use it as a biomarker, so as a way to see if somebody has Alzheimer's disease. So what we do is we draw the blood of different patients with Alzheimer's disease and patients without Alzheimer's disease, and we test their blood to see if they have this molecule. And if they do, then we can say, okay, what stage of Alzheimer's disease you're in. And so this is just a work in progress, and it'll take a while for us to determine a real test or a test that is going to be approved by all different kinds of scientists. And so that's essentially the main goal of our lab. And so the formula, actually, I know I said it's a small protein, but then I also said it's big. It's big in terms of a chemistry context. But if you talk about molecules that you can kind of write out the formula for, then it's really big. But as a protein, compared to other proteins, it's actually a small protein. And so I can't give you a formula for it because it's really big in a chemistry context. But I can tell you it's organic, and so it's made up of a lot of carbons and hydrogens. So in terms of interesting facts, I did tell you, everybody has this compound. It's not just patients with Alzheimer's disease who have it, But there are also a lot of different ways that you can prevent over-accumulation of this protein. And one way that some studies have shown to maybe work out is to take a compound called EGCG, which is actually a big component in green tea. And so it's not completely proven that green tea works, but a compound that is in green tea has been shown to kind of reduce the effects of amyloid beta aggregation in mice and in other beings, not humans, but that's still interesting. Alright, thank you for interviewing me, and I hope you all success in the future. Bye.